Hello and welcome, everybody. Today I'm going to be demoing a new tool we've been working on recently called Neural Net Inspector or NN Inspector, as you can see here on my screen. This is a web-based app that allows you to interactively inspect, diagnose model behavior to some extent, and just understand how neural networks are operating using real-world data. So I'm going to be going through just some of the main features here to demo the app for you. And one of the big features of this app is allowing you to use your own data, as I mentioned. So hopefully giving you an idea of how this might be useful either in your own research or for educational purposes or learning purposes for those who aren't really familiar with how sort of the structures of neural nets work when operating on real world data sets. So with that in mind, let's get started here. When you first start up the app here, again, this is a web app, so you don't need to install anything. There are no additional plugins, no additional libraries needed to run. This works on all major browsers as well as your phone. If you wanted to inspect neural networks on your phone, you could do that as well. Very basic HTML, CSS, JavaScript sort of setup for this here. And all of this is described in greater detail on our GitHub repository, as you can see here, which we've included a link to on the website there. This includes all of the information related to the features, why this sort of research is important, how to install and get started with this, configure some of your variables to point to the actual data you want to work with and what those data sets might include, the schema for how you need to load data into the network, all laid out here. And we've also included some very basic but useful TensorFlow callback functions to save all your weight, bias, activation information, that sort of stuff. So that's all included here in the GitHub repository, all these additional details. But we've made this model agnostic. It's very easy to run and use. And once you've got your data loaded and saved, you can point to it with this application here and begin looking at it in greater detail. Many people are familiar with multilayer perceptrons and what those look like when people think of a neural network with these directed acyclic graphs with nodes and edges, as you can see here on the left. But oftentimes, if you ask people to dig deeper into how these things actually work, it gets a little more complicated, right? And so one of the big features with this application is allowing users to really dive in, play around with, mess with the network in real time, and see how things change to provide sort of a deeper understanding of the network. So what we've got here is a precipitation phase classifier. This is a toy model just to sort of demonstrate how this works. It predicts at each minute whether or not the precipitation that's falling is rainfall, snowfall, or mixed phase precipitation, those slushy particles that you sometimes see. We've got a variety of different inputs on the left, things like temperature or relative humidity. Some of these might be more important than others if you're thinking about it physically. But again, understanding how these different features interact in the model itself inside the network is kind of tricky if you just look at it in terms of sort of the inputs and outputs. So what we can do is focus on this toolbar we've got at the top in blue here. We've got a variety of different options, including changing from a training or testing mode, looking at model information here. So what was used to train the model, this can be very useful. For instance, we're going to be using ReLU activation functions here and a categorical cross entropy loss function. These are automatically pulled in and displayed here based on the training specifications you would have used for your model, as I previously showed in the GitHub repository. And in the training mode, which we'll focus on first, this provides sort of an interactive surface level look at what all the weights and biases are at each step of the training process, as well as the loss curves and the accuracy curves if you're doing a classification problem, of course. And we can actually run this and animate the training over time. So if I hit play here, you can see all of the edges, the weights, and the bias terms, which are these terms below the nodes, update in real time. And you can see how these values change the loss values in each of the curves for your training and validation loss, as well as your training and validation accuracy. So I'll run that one more time here. We're doing 32 epochs here. One really interesting feature for this app as well is if you're interested in looking at intermediate models, so perhaps you don't actually want to use this final model at 32 epochs, you can play and you can pause or step through the model to any individual epoch you're interested in, and then you can work off of that version of the model. So this can be quite useful if you want to see how something trained with maybe only a few epochs, right? How that differs from a model that might be potentially overfit with many more epochs being used. Another feature that I'll just demonstrate really quickly here in the top interaction toolbar is the ability to change different features. You can turn different inputs in and on and off, and that will change, as you can see here, the structure of the network as we get fewer and fewer inputs on the left here. You can also change the number of neurons. You can make a very simple model, right, with only a single neuron. You can do 2, 4. These can be any values you're interested in. I'm just showing a suite of these here. 16 neurons, right? We're getting much more complex now with the structure. You can turn weights on if you want to see the individual weights for each of these different connections. But we've also got other options like turning on regularization and L1 like regularization in this case, that sort of thing. But for now, let's swap modes because I think really the power for this model is in its testing mode. So now we'll change this over to testing and we'll see the interface update. So we still have our network on the left here with our different loss curves and accuracy curves on the right, but now we've got a few new plots and some matrices on the bottom. So what we're doing here now is we can actually select from these test cases in the test sparsity plot on the right here, individual cases from the test data set that hasn't been used in training to see how the network updates its activations, right? So as I click through different cases in blue, which represent RAIN cases over here, you can see the network on the left is updating all of these activations, and we're predicting, in this case, since we're looking at RAIN cases accurately, rainfall through the networks. That's quite useful. If we move over and we look at these green cases, these are mixed phase cases. You can see again, different activations are firing, and now the mixed phase classification is being selected. And similarly, of course, for snowfall cases in orange here. Another interesting thing you can look at in the test mode here as well is the activation correlations. So what we do is by running the model through all of the test data, we can look at when sort of different activation values in the hidden layer fire compared to one another. We can calculate the correlations of those so you can get an idea of, along the diagonal, when a node fires, it will always fire with itself, right? So you'll always have a perfect correlation of 1 here. But on the edges here, you can see, for instance, for H0, this node at the top, when it's firing the H1 and it's positive, the H1 node is oftentimes off. So sort of giving you some indication as to how the relative activation functions fire across the entire network, which can be quite useful for seeing whether or not a neuron is more useful than not. And what I mean for that is if we look at the H2 neuron, which has sort of very low correlations with the other nodes, if we turn this neuron off here, you can see this sets all of the values that were in the neuron index 2 to blank since we're not using it anymore. These are all black and nan because we've turned it off just by clicking on it here. When we look at the actual scores and the metrics of the model, when we've turned this neuron off, you can see we still have a very high, Hideki scale score, 0.94, the proof of detection, false alarm rates, those are all still pretty good. In the confusion matrix of predicted versus, or actual versus predicted, still has very high values along the diagonal, indicating good performance, right? So turning this node on and off does impact things slightly, but you can see the performance is still quite good for this model with this many inputs. This was sort of expected because this is a pretty simple model, right? This is a toy model. But again, this can be used for any of your models with real world data. You can turn nodes on and off in real time, and you can start to see as we turn more and more things off, for instance, this node here, in addition to these other two, now the skill has gone to 0. We can only predict a single case here, right? We're only predicting RAIN cases now. The network has been disrupted enough, is maybe a way to put it, by turning these neurons off that it no longer performs in a way that would be useful for the user, right? So another interesting way to sort of interactively play around with your network to see how things change. Of course, you could do this in the code as well. If you're running things with TensorFlow or PyTorch or something along those lines, you can always turn things on and off there. But this is a much more accessible way to do it, in my opinion. And the platform that we've provided here is sort of a means to allow users to do so without having to have such a deep understanding of turning things on and off in the code itself and doing it in real time, which makes it a little easier to interpret and jump between different conditional cases here. Another thing that might be of interest is this LRP mode, this layer-wise relevance propagation feature, where you can look at individual cases and see how different inputs and different features are sort of relevant for that predictive feature. So one of the really big features that we want to incorporate with this model is the ability to do some sort of basic interpretability analysis. While this is an explainable AI technique, we think combining multiple of these approaches together and starting off looking at very simple models, for instance, maybe with only one neuron and a couple of inputs, understanding how when you add new inputs that contain physically meaningful information, that might change the accuracy and the skill of the model and give you some idea as to whether or not, for instance, this is just doing some temperature thresholding with this very high temperature weight for predicting snow, rain, or mixed phase. Another feature that goes along with this is the L1 or regularization ability that we've also added here. And we're planning to add more of these and make this a little more dynamic in the future. But you can change the number of inputs again, number of neurons, and see how when you change the regularization scheme, how that changes the model weights, as you can see here, giving you some input. Of course, L1 helps add feature sparsity to see which features are most important in contributing to model skill here. So we're thinking that in total, using this application, playing around with your models, we're hoping that that gives users some additional insight into their behavior with this idea of moving towards more interpretable models, more interpretable neural networks. Of course, these are only toy models, but understanding how these networks work is very important for understanding biases and trying to create sort of more trustworthy models in the future, which is especially important when we're dealing with physical models, physical variables that have really high impact to the daily lives of many people. So this is just a high-level overview. Thank you for joining me. Feel free to play around with this model, and we're adding, again, the ability and expanding on the ability to include your own data. Feel free to fork this and use our GitHub repository, again, as we've got here at github.com/affairsoftheking/inspector. Play around with this, add new features, again, use your own data, and try to really understand what your model is doing. Thank you, everybody.